This video is to allow you to correct your homework from section 9.2.2, homework problems 944 through 948. So it says in a bicyclist race, bicyclists rode 82 miles on the first day. The 82 miles represented 20% of the entire race. How long was the entire race? Write an equation and then solve to find your answer. So what I have here is how we would think about setting it up, which is that 82 miles is 20% of the entire race. But then we would have to use some type of variable to represent the entire race. You could use R for race, you can use X. That would be defining your variable. And then you would want to rewrite that equation so that it's set up in a way where you can solve it. So you would say 82 equals 20%, 0.20. Of means multiply, and then times the race length. So 82 miles is 20% of that race length. Then what you would want to do is to solve it. So right now, the variable is being multiplied by 20 hundredths. So the inverse operation would be to divide by 20 hundredths, or 2/10 if you got rid of that non-essential zero. And again, if you do it to one side, you have to do it to the other side. Okay. And then this would create your giant 1. And then you'd take your 82 divided by 20 hundredths and you get 410 miles. So you can see that I have it set up here as well. In this case, I put the variable on the left side. And again, it doesn't matter because as long as the 82 is represented on one side and 20% of the race is represented on the other side, it is fine. And again, you also notice I dropped the non-essential zero here, which is fine as well. All right, so that would be our setup. The other way you could set it up, I have written here. This, though, is probably not an equation. So this would be another way to solve it, but it's not really an equation, which is that 20% is 82 miles. We want to know what 100% is. And again, that would be something where you would do your cross product. So you take the 82 times 100 and divide by 20 times your x. And again, you end up solving and getting the same answer. B, if bicyclists rode 21% of the race on the second day, how many miles did they ride on the second day? Well, if we know the entire race is 410 miles, then 21% of 410, we would change that to 21 hundredths, because percent has a decimal is 0.21, times 410. And you can put that in your calculator and get 86 and 1/10 miles. And then after completing the first 2 days as described, the bicyclists have what percentage left to ride? All right, well, they did 20%, they said, on the first day. They did 21% on the second day. So that would be, of course, a total of 41% that they've done. If you take the 100% of the race minus the 41% they've completed, there's 59% of the race left. And then how many miles do they have left to ride? Well, again, we want to know basically what is 59% of that entire race, 410 miles. Change the percent to a decimal. Of means multiply. So you get 241 and 9/10 miles. Now, again, I know I went through that fairly quickly. It'd probably be smart to pause and make sure you've got all your work shown. You need to show your equation and how you solve it. You need to show these steps. All right, again, you're allowed a calculator, but show your work. 9:45. If Miss Westhagen can knit 5 hats in exactly 19 hours, how long should it take her to knit 12 hats? Show all your work or explain your reasoning. Again, there's more than one way to do this. I did it as a proportion. I said 5 hats out of 19 hours would be the same as 12 hats out of an unknown number of hours. So I should put my little lines in here to represent my proportion. So I can do 5 hats in 19 hours. 12 hats should take me how many hours? And again, you can then do cross products. 12 times 19 equals 5 times x. And when you do that and you solve, you end up getting 45 and 6/10 hours. Because you end up with 19 times 12 being divided by 5 to give you x. Then they want you to plot these points on a coordinate graph and find the length of each segment. Make sure that you have this done on graph paper, and then you've taken a picture and inserted it into your doc. I do not have the graph shown here, but I do have the lengths. So you would have to plot the point 3, 5 over 3 up 5, plot the point negative 8, 5, to the left 8 from 0, up 5, and then show that those have been connected, and the distance of the connection, the distance of the segment connecting those 2 points is 11 units. And then the same thing here. 2.5 units over, 3 units down, 5 and 1/10 units over, negative 3 units down. Difference between them is 2 and 6/10. Now, for something like this, you might say to yourself, how am I going to graph this exactly with the 2.5 and the 5 and 1/10? Those would be approximate. But in terms of finding the distance between them, we can find that exactly because the negative 3 units are the same. So really we want to know what is the distance between 2.5 and 5 and 1/10. Since they're both on the same side of 0, we're just subtracting them to get that 2 and 6/10. And so on. Okay. For 947, you're going to find the area and perimeter of each shape. Look at this shape, you could either think of it as a rectangle with a triangle on it for finding the area, or you can think of it as a trapezoid. Either way, make sure you're showing your work, and the same thing for your perimeter, make sure you're showing what you put into your calculator. So for the perimeter, for the first one, you should get 36 and 28 inches. For the area, again, show whatever formula you used, the trapezoid formula or the triangle and the rectangle formula. You end up getting 77 square inches. And then for the triangle here, the perimeter would be adding up the sides. You get 36 meters. Area of a triangle, of course, is base times height divided by 2. You get 60 square meters. Again, make sure you've got work shown. Show what you put into your calculator. And those formulas should be something that you have in your toolkit and probably in your notes. And then completing the portions web, if we know that we've got 87.5%, that would be the same if we move the decimal 2 places to the left as 875 thousandths as a decimal. That would also be the same as 875 thousandths in words. And then 875 thousandths, if you put that over make it into a fraction, 875 is the numerator, 1,000 is the denominator, it will simplify to 7/8. And then for the second one here, we've got 0.3 repeating, which that's a little bit tricky, but we know that 0.3 repeating is the fraction 1/3. And then if you think of that as 0.3333 and you move the decimal over the 2 places to the right to make it a percent, then you get 33.3 repeating. We would also take 33 and 1/3%. And of course, in words, you can say it as 1/3. So again, pause the video whenever you need to make sure you get that information down. If you have questions, feel free to ask. And that